Hi, my name is William, and I'm a PhD student at Brown University. Today, I'm going to briefly cover our paper, IsoScore. IsoScore introduces the first tool in the literature capable of measuring isotropy in embedding space. And we use IsoScore to study the geometry of point clouds induced by contextualized embedding models such as BERT or GPT-2. There's a growing body of literature that has studying the point clouds induced by contextualized embedding models. And the seminal work in this field argues that contextualized embedding models are anisotropic. So they lack this property of isotropy, namely they only utilize a few dimensions in space. And many authors come to this conclusion by looking at the average random cosine similarity between points in these embeddings. And we show that this is 1. So a lot of authors argue that this geometry, this lack of isotropy is undesirable. And in fact, if we can improve isotropy in embedding space, we can improve performance on some downstream tasks. Now, I can't give a talk on IsoScore and isotropy without defining what it means for a distribution to be isotropic. Now, a distribution is isotropic if the variance in the data is uniformly distributed across all dimensions in space. And what this means in practice is that the covariance matrix is proportional to the identity matrix. Here we have a line, a circle, and a sphere embedded into 3-dimensional space. The line only utilizes a single dimension in space, and thus lacks this property of isotropy, since all the variance is concentrated in a single dimension. In this circle, we have the variance equally distributed between the x and the y dimensions in space, and thus this is somewhat isotropic. And in the sphere, we have all 3 dimensions being uniformly utilized, and thus this is a fully isotropic space. Now, the most common way to measure isotropy in embedding space currently is this average random cosine similarity metric. Now, we can see that isotropy is strictly a property of the covariance matrix. It has nothing to do with the mean of the distribution. However, average random cosine similarity is highly influenced by the mean. If we look at these 2 black points sampled from this point cloud, we see the angle between them is very small, and thus the average random cosine similarity of these points, this entire point cloud approaches 1, meaning that this would be anisotropic under the current convention. If we simply apply a zero mean transform, the angle increases to 180 degrees, and the average random cosine similarity of the space now is 0. Now, in the convention, this means that the space is fully isotropic. But as we can see, the shape and the distribution of variance doesn't change in this point cloud at all. So the first aim of this project is to design a tool capable of accurately measuring isotropy. We then want to use our tool, IsoScore, to challenge and extend the current literature on isotropy in contextualized word embeddings. So I'll start by giving just a very brief intuition of IsoScore, and then I'll quickly describe some of the 6 essential conditions that we derive from the definition of isotropy in order to show whether a tool accurately measures isotropy or not. So since isotropy is a property of the covariance matrix, IsoScore is strictly a function of the covariance matrix. So what IsoScore will do is it will tell you how far away the covariance matrix of this point cloud in red is from the covariance matrix of an isotropic distribution. So this covariance matrix of this point cloud in blue. Now, we developed 6 essential conditions for measuring isotropy directly from the definition of isotropy. And if a tool is to measure isotropy, it must satisfy each of these 6 essential conditions. Now, I can't cover these in detail here, but if you're interested, please check out our paper on arXiv. Now, concerningly, average random cosine similarity and the partition score, which are the 2 most common ways to measure isotropy, only satisfy a small fraction of these essential conditions. And in fact, IsoScore is the only tool in the literature that satisfies all 6 of these essential conditions, and is the only tool that actually measures isotropy. Now that we've designed IsoScore, we want to use it to challenge and extend the current literature on isotropy and contextualized embeddings. And we do this by recreating an experiment by Kai et al. In 2021. We look at token embeddings from the Wiki2 text corpus, and we look at isotropy per layer in a variety of networks. Now, this graph here, we have the 5 different scores per layer of a variety of contextualized embedding models. Here, a score of 1 means that the embedding is isotropic, and a score of 0 means that this embedding lacks the property of isotropy. Now, we renormalize cosine similarity to fit within these constraints. The first thing that we see is that contextualized embedding models are less isotropic than previously thought. And we also see that these models do not necessarily become more isotropic in deeper layers. Now, there's been a connection between isotropy and performance in the literature, but the most common way of improving isotropy is by subtracting the common mean vector, which we know has nothing to do with isotropy since it's a property of the covariance matrix. We also know that these contextualized embedding models have these rogue dimensions that deviate really far from 0. So we have a few dimensions in space that deviate from the origin and have high means, so which is why the average and the cosine similarity is equal to 1. Now, in this project, we show that existing methods do not measure isotropy. We developed 6 essential conditions for measuring isotropy and show that IsoScore is the only tool that actually measures isotropy. Additionally, we apply IsoScore to embeddings to show that these contextualized embedding models are less isotropic than previously thought. Models do not necessarily become more isotropic in deeper layers, and this connection between isotropy and performance is no longer valid under these flawed metrics. Now, if you're interested in using IsoScore, here's a link to our archive. Our GitHub has all the scores and all of our tests coded up. And if you have any questions, please email me. Thank you so much for listening.